When we're dealing in what is called set theory, that is the math of describing objects that share properties or specific values, it's often very useful to be able to look at groups that come together from different parts, where the two main pieces we have for bringing these things together are what are called intersections and unions, where the intersection of two sets describes the values that are contained in both. That is, it describes only the shared values between a pair of sets, which is denoted with that little bump symbol. You can think of that as being like an N for intersection, or saying something like and. Meanwhile, unions describe the things that are contained in either set and has a symbol that looks like a U, so think U for union, that says something more like or. It says if there's this thing over here as well as this thing over here, I get the union, I'm getting all possibilities. Where, for those of you that have some experience with logic gates, might not be many of you, these operate in roughly the same way and with roughly the same notation as well as the and or gates. That wasn't really a nice way to say that. That didn't sound kind of funky. But this is a lot of talking about these things. Really, everything with set theory works best if you see a couple of quick, concrete examples. So we're going to look at one here. For this example, we want to find the set defined by the intersection of the closed interval from 1 to 3 and the open interval from 2 to 6. So the first thing that we might want to do here in terms of being able to find that intersection, that is, find the overlap between them, thinking in terms of a Venn diagram, this is something like that area shared in the middle. What we would have to do is first figure out what each of these things looks like, what's in each of them. So we might want to make ourselves a number line so we can see what 1 to 3 is, and then we can look at 2 to 6 and compare them, and then we can almost think of squashing them together and just seeing what happens that occurs in both, where the only thing that happens that occurs in both is the window from 2 to 3, where because we are excluding 2 from the second set, that is going to be open, and because we are including 3 in the first set as well as the second, that part's going to be closed. So looking at it graphically, we'd end up with something like this on the number line, or that the intersection of those two sets, 1 to 3, intersect. That should be a little bit smoother because we are open. 2 to 6 ends up being the half open interval from 2 to 3, or if you prefer in set builder notation, which we're still learning all of these things, I'll write anyway, the set of x values such that 2 is less than x, which is itself at most 3. And if we want to talk about a union, that would be something like, instead of saying the piece in the middle of the Venn diagram, the whole collection of the two bubbles, as it were. And just for reference, in this case, the union would end up being the half open interval starting at 1, including 1, and going up to 6, but not including 6. Anyway, now that we finally have all of our basic pieces for notation in mind, we can talk about actually describing the solutions to inequalities, starting with linear. Inequalities are our most friendly variety.